In this video, we're going to talk about custom experiments in AnyLogic. You probably already know that there are many built-in experiments in AnyLogic, such as the optimization, the parameter variation, the Monte Carlo, etc. But what if we want to make a new experiment that doesn't already exist in AnyLogic? This is where you can use the custom experiments. You can even use these custom experiments to replicate the experiments that are already there in AnyLogic. The main advantage of these custom experiments is that they provide you with great flexibility. So you will be able to use it to design any experiment you want and even add some graphical representation. And you will be doing that using coding. So what we are going to do is to try to replicate some of the experiments that are already found in AnyLogic, just to show you the general idea and the main concept of how to use these custom experiments. So in order to do that, we are going to make some examples on a very simple model. We had already used this same example model in a previous video of ours that also touched on the issue of experiments in AnyLogic. So we're going to use the same example model, but I'm going to pass you quickly through it again for you to know what this model does. It's a very simple model where agents enter to a system and pass through a delay and two services using resources from a resource pool. Now, in this service, the first service, the agents are only willing to wait a certain amount of time to be serviced. So if this time is surpassed, they will just leave the system before being serviced. And the main variable that we are looking to find is the number of agents that leave the system before being serviced. Okay, so let's see first how we can add a custom experiment. So the same way that we add a normal experiment, we just choose a new experiment, and then we choose our custom experiment and finish. Now, the first thing that you will notice when you add a custom experiment is that you will not get an experiment window the same as you do with the other built-in normal experiments. So, for example, in a parameter variation, you will get this window, and here you will get the possibility of choosing many parameters in an interactive way. In the case of a custom experiment, you will not get this window. Instead, what you will actually get is this space that is called code, where you already have some code built in, and you will also get a section where you can add more code, which is called the additional class code. Now, this code actually presents the same properties that we usually indicate in other experiments, but in an interactive form. So, for example, this function is used to set the seed. You can also set the time units. You can also set the starting time of the model or the starting date, as well as the stopping time of the run. And this function is used to specify the upper level agent that you can call from within this experiment. So if you notice, this is why in other experiments we usually use root in order to call our upper level agent instead of using main, for example. And then after specifying the upper level agent, you can now access the parameters in your upper level agent in order to set certain values for these parameters, or you can just keep them with their default values by using this function. And finally, these functions are simply used to start and stop the run of the model. So for now, what this code simply does is run the model one time with the values of the parameters set to default. So in order to customize the experiment to whatever we need it to do, we will definitely need to add more code to this, and we can do that using the additional class code. So we will start by giving an example of how to replicate a simple Monte Carlo experiment using the custom experiments. So the Monte Carlo experiment, as you probably already know, simply runs the model for a certain amount of time that we can specify, and we are going to make our custom experiment do the same. Since, as already mentioned, the custom experiment doesn't come with an experiment window, we can actually use the normal simulation experiment window in order to make our custom experiment more interactive. So we can add a button here that we can use to run our custom experiment. And this way, when we run our simulation experiment, we will have the capability to either use this button to run the custom experiment or use this play button to run the model normally as we usually do. Now remember that we cannot access our simulation experiment window from our custom experiment. And this is why what you are going to do is actually add a function in our custom experiment that accepts certain arguments that we can provide it with from within our simulation experiment window. And this function can also return certain types of variables if we need to send something back to our simulation experiment window. So this is what I actually did in this custom experiment that I have already prepared. I prepared a function and called it start round that accepts an integer as an argument. And this argument is going to be the seed that I'm going to use to feed this function in order to run my model using the seed. So what I did is simply to copy all the code that was here inside the code section and put it inside this function. And then finally, I added the function that traces or prints the value of the variable I am looking for at the end of the simulation run to the console. So for now, this is what the function simply does. It runs the model with a certain seed and it prints the value of the number left variable. So now what we still need to do is to simply call this function a certain amount of times from our simulation experiment window in order to run the model the certain amount of times that we want to conduct our Monte Carlo experiment. Now, in order to specify the number of times that we need our experiment to repeat running the model, we can either use an edit box where we indicate the number of runs, or we can even use an Excel sheet and link it to our model. And we can specify the number of times here and simply indicate in the initial experiment setup that we want our variable value to be equal to the value indicated in the Excel sheet. And finally, in the button that we need to press in order to run our experiment, we are going to add a for loop that will iterate for the number of runs that we have indicated. So in order to be able to call the function that we have added inside our custom experiment, which is the start round function, we will need first to initialize an instance of our custom experiment, and then we will use this instance to call for the function that we have added. And as we indicated before, we will need to provide this function with an integer, which is the argument, which is going to be used as the seed. In this case, we are going to simply use the I value which ranges from 0 to the number of rounds. And this way, our experiment will run for the number of runs that we have specified, and each time is going to run with a different seed. So let's run our custom experiment to see the results. So as indicated earlier, we can either put the number of rounds here, or we can use the value that we already indicated inside the Excel sheet. So I'm just going to use this one. And then I will press the button in order to run my custom experiment. And there you go. You can count the results and you will see that we have 10 results, meaning that we have run our model for 10 times, and every time at the end, the experiment traces the number of agents that left the system. Now, of course, printing the results to the console is not the only things you could do. You can store the results in an Excel sheet if you need to use the results in any way you want. So you can really do whatever you want. You can even add a graph in your simulation experiment window that shows how these values are changing. We are actually going to see how we can do that when we do another example using custom experiments. Another example we can do using custom experiments is to replicate the parameter variation experiment. So in this case, we will need to have a certain parameter in our model that we need to vary along a certain range. That's why the custom experiment is going to be very similar to the previous one. However, in this case, we are not going to set the value of the parameters to their default. Instead, we will change the value of the parameter that we want to vary. That's why we are going to provide our function with another argument, which is this parameter or the value of this parameter. And in this case, with every run, the experiment is going to set the value of the parameter that we need to vary equals to the value that we provide in this argument. So in this experiment, we will need to provide or to add three values in the Excel sheet, which are the minimum, which is the minimum value of the parameter, the maximum value, and the step, which means how much we want it to vary, which is exactly the same as the built-in parameter variation experiment in AnyLogic. And finally, the only thing left in this case is to do some calculation in order to calculate the number of iterations that we need to do based on the given, which are the minimum, the maximum, and the step. So in the example we are working on, our parameter is going to be the number of resources in the resource pool, and we are going to vary it, let's say, from 1 to 15 with a step of 1. So we do some calculation in order to calculate the number of iterations that we need. And same as before, we are going to use the for loop in order to run the model this certain number of iterations while providing our function with the value of the parameter in every run. Let's run our experiment. Remember that for now we are varying the parameter from 1 to 15. Okay, so I will start the experiment. And as you can see here, I'm tracing the value of the parameter and the value of the variable we are looking for. So as you can see, my parameter is varying from 1 to 15 as indicated in the Excel sheet. And as expected, as the number of resources in the resource pool increases, the number of people that leave the system decreases until it finally reaches zero. So now that you know how these custom experiments work, you can start thinking about more complicated experiments to do. In part two of this video, we are going to use custom experiments to apply two new very interesting experiments, so stay tuned.